Hello everyone. So today's POTD is maximum level sum of a binary tree. So this is the problem, medium problem. Here given it is the root of a binary tree, the level of its roots is 1, the level of its children is 2 and so on. So basically this one G1, this one 2, this one 3. And here need to return the smallest level x such that the sum of all the values of the nodes at level x is maximal. So what it uh, telling exactly, find the sum of all the level and uh, then take the maximum sum of each level. So out of all the sum, suppose here we got 3 sum, and out of 3 need to um, figure out which level have maximum sum. Then in case of equal, then we need to, this smallest one will be in use. Otherwise, in case of all the sum would be unequal, then maximum sum corresponding level should need to return. So here in this case we can see 1707 minus 8. So here 1 7 plus 0 7 7 minus 8 minus 1. So here all level sums are unequal. So here in level 2 need to return. But in case of equality happens, suppose level 7 this here instead of 1 7 and here 7 0, then we need to return only level 1, not 2. So similarly this case here 9 8 9, then null, then 10 250 98693 in another this further children, and then need to return this one because 10 250, that particular node level is the largest sum. So here let's see the constants of this problem. The number of nodes in the tree is in the range of 1 in 10 1 comma 10 to the power 4. So yeah, and node value also here. So let's try to figure out how to solve this problem. So I'm thinking to solve this problem by using the traversal, each level traversal, and once we will get each level traversal, we anyhow we need to find out the sum of each level. So here need to build the intuition. Main intuition is here. So how anyhow we can able to find out the sum of each level. So here suppose here number of levels, so we need to find out the separate sum of each level and then comparing as well. And then after that we can figure out, after comparison we can figure out to which sum is maximum and corresponding level also. So anyhow we can think of at, at at the same time we need to figure out the maximum sum as well as uh, which level. So we need to somehow make a counter to track the level as well as make a variable maximum sum which will track the maximum sum. So anyhow I'm thinking in that way. So let's try to figure out. So main data structure here, usually we use the queue data structure, so which will help us to figure out the each level traversal. So let's do it here. So yeah, I'm doing just writing the code. So firstly need to declare the queue data structure, and then I'm here just entering. I'm just pushing the first value of the node, or we are exactly pushing the node in the queue data structure. So let's make the uh, final, what is the counter, what I discussed, counter equal to 0, that let's name is CNTR, that would be small. And after that, tracker, it will tracker, we can name it tracker, that will track the level, level tracker, let's name it level tracker. And let's, so here what we are doing, we are just taking the value, basically whatever size of the queue, sorry, I'm just making the size, taking out the size of the queue data structure. And secondly, need to queue dot pop, not exactly here, I'm just making here. Okay, firstly need to figure out the what is the size of the queue, and then after uh, let's make a for loop, and just making taking the variable s equal to 0. So here what we are doing, s equal to 0, it will store the sum of each level. And every time I will store the whatever is stored in this q dot front, and then q dot pop here. And simply what uh, we will do, once we will extract it out q dot front, okay, then let's check out the next element in the queue. So basically what exactly I'm thinking about here, need to, okay, hmm. So yeah, yeah, I got it. So here value, okay, and here need to figure out one thing, I need to store int. Every time I need to store, and just check in node left not equal to null, then just what we are doing, just storing here. And similarly what we are doing here, node right. And yeah, after that we simply increase the tracker, this would be level tracker. And I will just compare the value of the exactly the storing value. So yeah, so let's declare the variable int mini equal to max equal to int min. So let's compare maxi less than s, then simply max equal to yes, and And second thing, storing the f equal to final value would be the label that would be I will simply store, need to declare here uh, f equal to 0, and then this is final value, this is level tracker. So here need to, yeah, level whatever level tracker and here final value, this is final value, this is level tracker. So let's uh, after that, yeah, just need to return the f. Hope it will work. Yeah, it worked. So let me explain you guys what we have done. Basically making a queue, and after that pushing, just push the root of, of the tree, and then storing here final value, final level we can say, and here tracking the level, and simply storing answer, the answer, storing the answer maximal sum of the particular level each time, and just comparing here, just queue traversing level order traversal we can say. And again we are checking here left and right, and just here doing the just uh, popping out first front element or first element from the queue, and then again adding in yes, that is the every level some every some level some tracker. So here we are again checking here and storing here f in f, and then max, and yeah, simply we are returning. So this is around how many line of code it is, this is 38. So yeah, not more than around 20 to 24 line of code. Yeah, let's submit it. Yeah, it passed, Jerome. You can, that's, yeah, that's all for today. Let's